Astronomical Society of Victoria, with the regular Friday night broadcast coming to you from the studios of VK3CSJ in Narre Warren South. We're broadcasting on prime frequency of 3541 kHz in the 80 metre amateur radio band and simulcasting on 160 metres on 1865 kHz SSB. We're also streaming via the YouTube channel, my YouTube channel, which is VK3CSJ. By searching into the Google YouTube search engine, you'll find that easily enough, and look for the little live symbol, and you'll be able to see the stream there. There's plenty of graphics tonight, so it would be advisable to if you have a computer in the shack, to activate the YouTube channel as such. Anyway, we'll also have a email address, vk3ekh@gmail.com, vk3ekh@gmail.com, and also a Discord chat window which can be found via the ASV website at www.asv.org.au. Unfortunately, there's no television repeater tonight. Once again, the Melbourne Digital TV repeater is down for maintenance, so unfortunately we're not broadcasting HD through the Melbourne TV repeater tonight. Hopefully that'll be fixed in very soon, but we do have a few gremlins in that area, so it's strictly YouTube tonight for all the visuals, and I apologise for the natural delay it's incurred with the YouTube channel as opposed to the audio direct here on HF. Now, before I go on any further, I want to humblest apologies to a station last week, an official apologies to Jim, VK3 UFO. I inadvertently came up on the frequency without checking the frequency, so I received a polite email from a fellow amateur who just indicated that I came up almost on top of Jim, and I would have, if I had have known that, I would have not done that. I would have come up on frequency more appropriately. So apologies to Jim if you're listening there. Look, it's something I've got to fix this end. I have one common speaker between two radios, so I've got to select speaker A and speaker B for the output of 160 and 80 meters, and I thought I had it on 80 meters, so there it is. But humblest apologies, so I get that right off the bat and get that over. I'll also say that this is the last QSO, the last broadcast for 2022. I've decided to make this the last transmission for 2022, and I'll be back on the 27th of January next year. So it's a good month off. The process is to do a little bit of modification to the Radio Shack and a few other things that have to be done in this place, and hopefully, if all goes to plan, we'll be coming from Studio C downstairs in the near future, and hopefully things will be set up a little bit more appropriately for operating this station. So this is the last broadcast today. All right. Now we have, like I said, we have a few things. There's a I'm going to play a podcast tonight from Brendan O'Brien's Astrophiz podcast site, and we'll have that running in just a short moment or two. But before I do, just the usual thing about the station, or about the society in general. The Astronomical Society of Victoria, founded in 1922, has well over 1,600 members throughout Victoria and Australia and overseas, including overseas. Membership of the Society is open to all persons with an interest in astronomy. The Society's objectives are to encourage the study and the practice of astronomy, and to disseminate the knowledge of the science, and to provide greater facilities for the study among its members. Monthly meetings are usually held on the second Wednesday of each month, except in January, where the latter being held on a Saturday night. Meetings start at 8 p.m. at the Morley Hall, National Herbarium, in Burwood Avenue, Melbourne, near the Melbourne Observatory, which is located not too far from the Shrine of Remembrance. Parking is available in Burwood Avenue, Dallas Brooks Drive, and the surrounding streets. Admission is free, and visitors are most welcome. These meetings are also conducted on the ASV's YouTube channel. They are broadcasted live on the ASV's dedicated YouTube channel and also on Facebook's the ASV Facebook page. Privileges of membership include the right to borrow books, periodicals and other publications from the Society's extensive library located at Melbourne Observatory, receipt of the ASV magazine Crux containing articles, news, observing notes and the like, and the free provision of the Astronomical yearbook. Access is available to telescopes on members' nights held regularly at Melbourne Observatory and after the monthly meetings, weather permitting. These instruments include the Society's 300mm equatorial reflector and a 300mm portable reflector. There's also a 200mm refractor, which is managed by the Royal Botanic Gardens, and a photoheliograph are also housed at the observatory and are accessible as well. The Society also has a number of 200mm reflectors available for short period loan, so members can try before they buy. Members are also encouraged to make use of the Society's country property located near Heathcote, some 90-minute drive north of Melbourne. There are a range of instruments available for members to use, the larger two only with appropriate training, which range from 300mm to 1000mm in aperture. Also located on site is the 8.5 fully steerable radio telescope, which members can access with involvement in the radio astronomy section. Members are encouraged to make and use telescopes. Advice and help on both matters are provided willingly to newcomers desiring to do the same. Instrument making is only one of the number of common interest activities catered for within the Society. Other areas of interest that members can participate in include deep sky observing, astrophotography, lunar and planetary observing, auroral, meteor, comet and radio astronomy, computing, cosmology and astrophysics, historical studies and research and astronomy in general. Contact details for various section directors are provided in the yearbook. Further information may be obtained by visiting the ASV website, and notifications of events are given in the Crux Extra bulletins sent out via email to members on every other week. Please note that the ASV will conform to all government health directives. ASV events may be required to be cancelled, moved or postponed. Otherwise, you can, if you want to contact the ASV, you can write a letter to the Secretary of the Astronomical Society of Victoria, GPO Box 1059, Melbourne, Victoria 3001. That's the Secretary, Astronomical Society of Victoria, GPO Box 1059, Melbourne, Victoria 3001. So, these broadcasts have been running since 1988, and more information about that, of course, can be found on the ASV website under the Radio Astronomy tab. Look for the ASV broadcast on the pull-down box. And also on the QRZ.com page, just type in VK3EKH, QRZ.com, and more information about the station, including a few pickies there, which will be upgraded in due course too, on the station here. So you're tuned to ASV Radio, VK3EKH, and tonight, because this goes for about 28 minutes, we have a podcast courtesy of Brendan O'Brien, the astrophys.com website. Brendan O'Brien hosts a fabulous fortnightly astronomy podcast about astrophysics, astrophotography, space science, particle physics. Listen to a different special guest each month, plus his regular Sky Guide feature with Dr. Alan Astroblog Musgrave. Now, he's I did hear somewhere that he's taking a bit of a break over Christmas, so there won't be anything fresh on his website for a few weeks. Much the same here. So, but nevertheless, check out his website, astrophys.com. There's 162 podcasts there, and mostly featuring professional astronomers talking about their field of interest. And tonight, this particular podcast, which is very, very fresh, it's just off the press, is Dr. Manisha Caleb, and she'll be talking about fast radio burst mysteries and the research that she's involved with. So, on that note, we'll get straight into that, and that'll be followed by the latest solar report from our space weather woman, Tamitha Scove. And if we have time, there'll be just a couple of quick, interesting little articles that have come through. So let's see if we can get this podcast running, and yes, back and listen. It's quite an interesting podcast. Thank you, Brendan O'Brien. Is that it? No, that's not it. Just a sec. Give me time to get that right. Okay, stand by. This is VK3 Echo Kilo Hotel.
Welcome to the Astrophiz podcasts. First of all, we would like to acknowledge Australia's first astronomers, the Aboriginal and Torres Strait Islander people, the traditional owners and custodians of the land we are on. This episode is produced on Yorta Yorta, Pangarang and Kaurna country. My name is Brendan O'Brien, and today's Thursday, the 15th of December. We always include a community service announcement asking you to wash your hands regularly, wear a mask if you can't socially distance effectively, and isolate as much as possible, and as soon as you can, to protect yourself and your community, get that COVID-19 vaccination as we work our way through this global crisis. We also ask you to influence your local politicians with the message that we need to change our energy policies to move to renewable energy to mitigate climate change. Each month we bring you 2 fabulous episodes. On the first of each month you'll get to hear Dr. Ian Astroblob Musgrave bring you his monthly Sky Guide, an astro treat for naked eye observers, telescopers and astrophotographers, and he always includes a tangent of astronomical wonder. In the middle of each month, we'll give you an interview with a noted astrophysicist, astronomer, astrophotographer, space scientist or particle physicist. But right now, we are going to cross down to Sydney, Australia to get the latest FRB research from Dr. Manisha Caleb. Hello again, Manisha.
Hello.
Today I'm really excited to be speaking again with an amazing researcher and astrophysicist, Dr. Manisha Caleb. Manisha has used the world's most powerful instruments to unlock the secrets of some of the most powerful and puzzling objects in our known universe. Thanks for speaking with us again today, Manisha.
It's an absolute pleasure to be here. I'm really excited for this interview.
Oh, thank you. Okay. Now, just before we talk about your research, I'll do a short recap for our listeners of the interview you kindly did with us 5 years ago in 2017, just before you submitted your thesis for your PhD. You told us about growing up and early studies in the metropolitan city of Chennai in India. Then you went over to London where you did your master's degree, which included identifying neutron stars in X-ray wavelengths, which in turn led you on to a personal focus on radio pulsars. And then you told us about your move down to Australia to pursue your astrophysics PhD at Canberra's Australian National University, where you were introduced to the Molonglo radio telescope, and you were also introduced to Professor Matthew Bales at Swinburne University. We've interviewed him in the past, and he worked with you as one of your PhD supervisors as you took a very deep dive and most productive research program into the phenomena of fast radio bursts. And your thesis, A Pursuit of Fast Radio Transients with the Utmost and Parkes radio telescopes, it was accepted, of course, and your doctorate was awarded not long after we did that first interview with you. Now, UTMOST is a research program attached to the Molonglo Observatory Synthesis Telescope, situated not far from Canberra in Australia, which you helped to refurbish and reconfigure. Then, straight after graduation with your doctorate, you took up a 4.5-year postdoc at the University of Manchester in the UK. And I had a look, and this was your address at the University of Manchester. Manisha Caleb, Jodrell Bank Centre for Astrophysics, Alan Turing Building, Manchester. What an amazing address. And surely you had an amazing time there, Manisha. We'll put our science hats on in a minute, but first, would you like to tell us some of your personal highlights for you up there in Manchester?
Thanks for that introduction, Brendan. Manchester is a very lively city, and the University of Manchester, I think, is a great place to pursue radio astronomy. I was part of the MEA-TRAP project led by Professor Ben Stappers at the university. So this was a European Research Council funded program. And I got to work on data from the Meerkat radio telescope, which is a pathfinder to the Square Kilometre Array, or the SKA. Also, Manchester is not only home to Alan Turing, but also the Lovell telescope at the Jodrell Bank Observatory.
Fantastic. Well, about Jodrell Bank and the Lovell telescope, would you like to tell us about this magnificent instrument?
Oh, I'd love to. So the Lovell telescope was commissioned in, I think, 1957, and it played a very prominent role in Britain's observations of the Sputnik satellite. And in fact, the telescope was also involved in the discovery of many of the early pulsars, the first gravitational lens, and the first millisecond pulsar in a globular cluster. Currently, the Lovell telescope monitors pulsars and fast radio bursts. And during my time at the University of Manchester, we used to go down to the Lovell telescope at the Jodrell Bank Observatory every Tuesday and spend the day there doing research.
Cool. Fantastic. Okay. Now, I've recently looked at all your lead author and co-author and collaboration papers that you've published during your time at Manchester, and it's an amazing body of work. And you have used some incredibly powerful instruments from top observatories all over the world, and you've worked in some wonderful collaborations. I know we're really not allowed to have favourites, but would you like to tell us about perhaps one of your most memorable research projects that you worked on while you were up there at Jodrell Bank?
So most of my work when I was in Manchester was with data from the Meerkat radio telescope in South Africa.
Yep.
Meerkat is an interferometer, and it's currently the most sensitive radio telescope in the Southern Hemisphere. And this will eventually be integrated into the mid-frequency component of the Square Kilometre Array, or the SKA, which will go on to be the world's largest radio telescope in the coming years. I thoroughly enjoyed my research and working with the MEA-TRAP team on all my projects, but if I had to pick one, it would have to be the discovery of an ultra-long period neutron star. Neutron stars are extremely dense remnants of supernova explosions, and most are born rapidly spinning and emit radiation from their magnetic poles, much like lighthouses. We call these neutron stars pulsars. Using the MEA-TRAP backend instrument, we discovered a very unusual radio-emitting neutron star, which rotates every 76 seconds. Now, until then, the slowest known pulsar or neutron star was about 23 seconds. So the 76-second source is unique because it resides in what we call the neutron star graveyard, and we don't really expect the sources to pulsate or produce any emission when they reside in the neutron star graveyard. So we fondly refer to this source as zombie star. What's interesting is the source exhibits 7 different pulse shapes, and this is truly remarkable because we haven't seen such a diversity in neutron stars before. The pulse itself is only on for about 300 milliseconds of the 76-second period. So it's on for about 0.5% of the time. So we were really lucky that the beam crossed the line of sight of the Earth. What's interesting is the source has certain characteristics of a pulsar, but it also has the characteristics of a magnetar. So the jury's still out there on what this object could possibly be. The magnetar scenario makes it particularly intriguing because theorists believe that ultra-long period magnetars could be the progenitors of the enigmatic fast radio bursts. We're going to have to continue monitoring this object to see if it can produce bursts with FRB-like energies, because FRBs are extragalactic and they have much higher energies than this galactic source, which is in our own galaxy and has energies which are much lower. There's a very nice conversation article about this 76-second period radio source.
Fantastic. Look, I'll look that up and I'll provide the link to that. Yeah, what a fascinating bit of research. Fantastic. Now, you mentioned Meerkat being the most powerful radio telescope in the Southern Hemisphere, and we do know about your work working with the Molonglo Observatory Synthesis Telescope. What are your thoughts of the Canadian FRB research that's coming out of the CHIME telescope?
Now, a few years ago, the ASCAP telescope here in Australia doubled the number of known FRBs, but even then, we only had about 50. CHIME in Canada has a massive field of view of about 250 square degrees, and this is about 1,200 times the size of a full moon. So this massive field of view is hugely beneficial for finding new FRBs and also monitoring known FRBs for repeat bursts simultaneously. The current published number from CHIME, I think, is about 550, but there are yet more to be revealed. Yep. Large numbers like this are great for population statistics, but in order to truly begin understanding the origins of FRBs, we need to pinpoint their localization upon discovery. And this is what telescopes or interferometers like ASCAP and Meerkat aim to do. But the planned upgrade for CHIME in the near future should be able to do this. And I think when it does come along, it's going to be a force to be reckoned with.
Fantastic. And for listeners that want to follow up on some backstory on that, we have done interviews with Jane Kaczmarek, who's working up there now, and also with Cherry Nguyen. Okay, so what about now? Just before we put our science hard hats on and take a deeper look into FRB research, and before we look at what might be causing FRBs, can you give our new listeners a sort of primer or brief summary of what a FRB is and how they are detected?
Absolutely. So fast radio bursts, or FRBs, are currently one of the biggest unsolved mysteries of modern day astrophysics. They're these bright radio flashes in the sky traveling towards us from halfway across the universe. They last about a few thousandths of a second, and in this time, they emit as much energy as the sun would in an entire day. We estimate a few FRBs to go off every minute in the sky at random locations. So they're very easy to miss in the blink of an eye. And if you're not pointing at the right patch of sky, they're quite easy to miss too. They're mostly observed as one-off bursts, but some of them have been observed to repeat. And it's presently unclear whether all FRBs repeat. What makes them exciting, though, is that they are cosmic messengers. So the signal from an FRB can be thought of to be a flashlight illuminating everything along the path. And as the signal bears the imprint of the material that it passes through, it is a goldmine of information about the cosmos.
Yep.
Now, the human eye can only detect visible light, which are basically the colors of the rainbow. But FRBs are seen only in radio light, which is beyond the red end of the visible light spectrum, so it's invisible to the human eye. We use radio telescopes to detect FRBs, and these show up as blips or little peaks in our data. The field has really exploded in the last couple of years, and we are currently in a worldwide race to figure out what these FRBs really are.
Fantastic. Okay, that's a good starting point for our new listeners. So what about now? I see you've moved from the UK back to Australia, and soon you'll be lecturing physics at the University of Sydney. But in the meantime, you're leading a well-funded DECRA grant project to use fast radio bursts to investigate the nature of stars and matter outside our galaxy. Can you tell us about the scope of this project and who's working with you on it, and what's the timeline, and What's your goals for this project?
With FRBs, there are many unknowns, but the nature of the object producing the FRB, I think, is the biggest one. So my DACRA focuses on probing the immediate environments of the sources of FRBs and investigating whether this could tell us something more about their nature. So there are a lot of FRBs which have been pinpointed to very precise locations with interferometers like MeerKAT and ASCAP. And these are the FRBs that I'm going to be targeting, irrespective of whether they repeat or not. Now, we've seen a handful of FRBs to repeat, and a couple of the most prolific repeaters in particular appear to be embedded in extremely magnetic environments, and they also seem to be associated with radio emission that persists over month to year timescales. The goal of my DACRA is to investigate whether non-repeaters too have such environments and explore the possibility of a unified population of repeaters and non-repeaters. For example, repeaters may be extremely energetic young objects with high magnetic fields and embedded in, say, a supernova remnant. Non-repeaters, on the other hand, may be older, less energetic, the magnetic field may have decayed, and the supernova remnant might have dissipated. Basically, repeaters and non-repeaters may just be different evolutionary stages of the same object. So we only have small number statistics at the moment, so deeper investigation is warranted to investigate this possibility. My DACRA is for 3 years, and I'm primarily working with Adam Deller and Matthew Bales at Swinburne University.
Fantastic. Okay, well, when we were talking about FRBs 5 years ago, a lot's happened since then. Localization was just a dream then, and we had no optical counterpart, but now we have host galaxies and we've got multi-messenger identification. And back then, I think we had about 50 hypotheses about the possible origins of FRBs, most of them cataclysmic. And since then, the field has been narrowed down a bit. And now that dozens of repeating FRBs have been discovered, is there an emerging consensus about what the origins of FRBs could be?
It really is amazing how radically the field has progressed in 5 years. And like you said, over 50 progenitor model theories have been proposed for FRBs, and they range from flaring magnetars and the destruction of highly magnetized white dwarfs to more exotic ones involving interactions between axion stars and black holes. Magnetars, which are a type of neutron star characterized by powerful magnetic fields, have always been a favorite right from the initial stages of the field.
Yep.
And in fact, the recent discovery of an FRB-like pulse from a magnetar in our own galaxy adds credence to this theory. Currently, I think the jury is still out there on what the progenitors of FRBs could be, but I think the objects that can most elegantly account for all the observables are neutron stars, and this is what most astronomers are leading towards.
Thank you. It must be fantastic to be right there in the middle of one of the greatest scientific mysteries and watching it unfold. Now, you've hinted at this. Right now, we're at the end of 2022, and what's the most exciting or puzzling bit of FRB work that's happening right now?
When I started my PhD, simply finding an FRB was amazing, but I think long gone are the days when finding an FRB was exciting. We've now reached a point where radical changes happen on timescales of just a few weeks. The better we can characterize the radio bursts and any possible associated multi-wavelength emission, the better our chances are of identifying the underlying emission mechanism and really beginning to understand the progenitor and the nature of the object producing these FRBs. The full potential of FRBs will only be realized in the era of routine FRB detections and corresponding host galaxy identifications and associations, which I don't think we're too far from now, actually. The future of FRBs lies in using them as probes of the extragalactic universe in complementary ways to, say, galaxies and even supernovae. Though FRBs started off as primarily radio astronomy, they seem to have formed a bridge across all astronomy, right from high-energy astrophysics to stellar astronomy to even cosmology. And in fact, an excellent example of this was solving the missing baryon problem using FRBs discovered with the ASCAP telescope.
Yep.
We know that the universe is made up of about 90% dark matter and dark energy, and only 5% is baryonic matter or normal atoms. Intriguingly, a census of the stars, galaxy, and the gas within and around them only accounted for half of this 5%. The remaining matter was out there hiding somewhere. Computer simulations predicted that the majority of the missing matter was hiding in the warm, hot intergalactic medium. But at that time, there was no real way to confirm its existence. And this is where FRBs came in. So when radio waves pass through matter, the longer wavelengths are briefly slowed down compared to the shorter ones upon interaction with this matter. And by measuring the spread of the different wavelengths within one FRB, we can calculate exactly how much matter and consequently how many baryons the radio wave has passed through on their way from the source producing the FRB to the Earth.
Yep.
By using a handful of FRBs, the ASCAP team and astronomers using the ASCAP telescope were able to make a rough calculation of how much matter the radio waves passed through before reaching the Earth. And would you believe it? It was consistent with what was missing. So astronomers now have proof that the warm, hot intergalactic medium exists and have confirmed how much there is, but we don't quite exactly know how this is distributed in the universe. And this is something for the future with more FRBs and more host galaxy associations.
Fantastic, and great news for those researching the cosmic web and cosmology. What a great resource the FRBs are turning out to be. Okay. Look, now might be a good time to ask how the current worldwide COVID-19 crisis has impacted on your research. You were over in Manchester for the initial COVID outbreak, probably thinking of your family back home. And the first 2 years of the pandemic, you were over there as well. What are your personal and professional reflections on COVID-19?
I think when the pandemic first started, we didn't really take it too seriously. And even when the university shut down initially, we expected to go back to work in a few weeks. So staying home for months on end was not something I was mentally prepared for. On the work front, it was business as usual because all I needed was internet and a laptop to get work done. It was quite isolating though, as almost everything was on Zoom and in-person interactions were almost close to zero. I quite missed the impromptu coffee breaks and random chats in the corridor. It was also a bit of a struggle to separate my work from my personal life. Personally, I think I got more work done during this period, and I was also able to give more talks as everything was online, so you could accommodate for different time zones, but it did come at a price. On the bright side, COVID has shown us that flexible working is possible, and most people work from home 2 to 3 days a week now.
Okay. You've also done a lot of outreach work as an early career astronomer, and in this next phase of your career, is outreach still important? Do you still involve yourself with outreach? What's next for you?
A lot of people think science is difficult, and outreach kind of helps overcome that notion. It helps communicate a scientific concept in a way that's both accessible and entertaining to the public while painlessly increasing their science knowledge. I strongly believe that it also encourages and inspires future generation of scientists. I do try and involve myself with as much outreach as possible. One of my favorites is the Blue Dot Festival, which is a science and music festival that happens every year at the Jodrell Bank Observatory in Manchester in the UK. My most recent one was the press release we did for the 76-second period neutron star, and hopefully there'll be plenty more on fast radio bursts in the near future.
Fantastic. Okay. Now, 5 years ago, I asked you this very same question. And back then, you clarified the problem that we have with the lack of women at all levels in science. So the mic is all yours again, Manisha, and you have the opportunity to give us your current favourite rant or rave about one of the greatest challenges that we face in science. The microphone's all yours.
Funnily enough, 5 years ago when I did this interview, I was a PhD student and now I'm faculty at the University of Sydney. So several universities are making conscious efforts to represent diversity and gender equality in more senior positions. I recently gave a talk to early career researchers, and the discussion that followed really highlighted the lack of mentors for early career researchers. I think that good mentors and career guidance is definitely something that is very important to early career researchers, irrespective of whether they decide to stay in academia or not. I consider myself very lucky in that aspect that I had amazing PhD supervisors, and my line manager at the University of Manchester was a brilliant mentor who was very supportive of my career growth. I aspire to be that to my students in the future.
Fantastic. And yeah, you're lucky students. Thank you. Now, just before we close off, is there anything else we should watch out for in the near future? What are you keeping your eye on?
I'm going to say fast radio bursts and ultra long period neutron stars.
Yep.
There's just so much going on in the field at the moment that it really is a roller coaster ride. With FRBs, we're finding ones that are further and further away, giving us insight into the tapestry of the early universe. Ultra long period neutron stars are an emerging field, and we're currently where we were with FRBs in the initial stages, I think. There are theoretical links between FRBs and ultra long period neutron stars, but the observational evidence is what is lacking at the moment. This potential link between ultra long period neutron stars being a possible progenitor of FRBs is something that really excites me and something that I'm keeping my eye out for.
Fantastic. Well, thank you so much, Dr. Manisha Caleb. I've been sitting here with a smile on my face for over half an hour now. On behalf of all of our listeners, and especially from me, it's been really fabulous to be speaking with you again, and you're an inspiration, and I hope I get the chance to meet you in real life one day. But thank you especially for your time and your amazing schedule, and good luck with your research. They will enjoy the experience as much as you, and good luck with all your next adventures. Thank you, Manisha.
Thank you, Brendan. Bye.
As promised, a nice summary of Manisha's neutron star research can be found at tinyurl.com/neutron76, or for those who want to read the whole research paper, it's on the Manchester University portal at tinyurl.com/neutron76pdf. That's neutron76pdf, all one word. It's also available for those with access to nature astronomy via their institution.
We have multiple filament launches on the Earth-facing disk, but is it more bark than bite? The stories and more in the news this week. This space weather forecast is sponsored in part by Millersville University. Come get certified in broadcast space weather. Visit millersville.edu/SWEN. Space weather this week is keeping us entertained. As we take a look at the Earth-facing disk, look at all the bright regions and all the snake-like filaments all over the Earth-facing disk. In fact, back on the 9th, you can see a filament in the south. The top part of that filament launches, and it looks like it goes Earth-directed, but it actually goes a little bit to the east of Earth. Nonetheless, it could still give us a glancing blow here right around the 13th. We also had a big filament eruption near region 3163 that launched off to the east. We'll take a better look at that in stereo's view. And then as we move to the 11th, you can see at the bottom part of that same filament that launched on the 9th, that lets go, and that now is going to go south of Earth. So there's another missed solar storm opportunity. And then on the 12th, you can see a little bit in the north, there's a filament that lifts off and goes north of Earth. So my goodness, there's so many different eruptions happening all over the place, but none of them are really all that spectacular, and they're not going to hit Earth or give us really any big show. Meanwhile, we have no less than 9 active regions on the Earth-facing disk. Only a couple of them are just barely big flare players. In fact, region 3163, that's the region that was rotating into Earth view on the 9th and gave us a nice launch, a beautiful solar storm launch. That region actually has kind of quieted down a bit. We also have a couple regions on the Earth's west limb, or the sun's west limb, that are rotating out of view. And as those disappear, boy, that M-flare risk really begins to die down. So amateur radio operators and emergency responders, it doesn't look like we're going to have a very big chance for radio blackouts, and that's good news. But with all these active regions in view, definitely that solar flux is staying up into the triple digits, and that means good radio propagation on Earth's day side. Switching to our M-flare threat meter, as you can see, about a week ago, the X-ray flux was sitting just below the seafloor, and that meant that the solar flux was doing okay, but it was kind of getting a little bit low. We were still in triple digits, but not by all that much. But as region 3163 began to rotate into view, you can see right there on the 9th that X-ray flux began to ramp up, and we thought, oh, whoa, this region might really be a big flare player. In fact, it did begin to perform a little bit, and then right around the 10th, it just kind of leveled off, and it began to fire kind of like an old faithful, just pop, 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 C-class flares, and never really gave us any big flares. So we haven't been getting much in terms of radio blackouts, just kind of a bit of noise on the bands. And now that the other regions, region 3153 and 56, are rotating to the sun's far side, we might see this X-ray flux dip, but just a little bit. The bands may quiet down just a smidge, but we're still, with all the other active regions on the Earth-facing disk, we're still going to get enough solar flux to keep us in the good range for radio propagation, and these conditions will easily continue throughout the rest of this week. Switching to our solar storm conditions, we've really been underperforming when it comes to solar storms. In fact, the last time we actually had some sustained storming was clear back at the beginning of the month. Back then, we actually had multiple days of active conditions or even storm levels, and we actually had some clear skies over North America, and so we got some gorgeous aurora that even dipped down into the upper tier of the United States. And then also, we actually had some nice period of southern hemisphere aurora as well. So we had some good aurora australis during that time. Then we kind of quieted down and we bumped back up right around the 4th, and that actually was a view that was more for those across the pond. In fact, we had some clear skies over Norway for a bit, and we even got some aurora near Denmark. So that was some gorgeous views, including those also in Scotland, and we'll talk about those later. And now everything is just kind of quieted down, and we're really just kind of in a hurry up and wait mode. So aurora photographers, there's nothing big on the menu yet. You're going to continue to see conditions just like this, and if you're at mid-latitudes, well, I'm afraid you're just going to have to sit tight. And although the solar storms over the past couple weeks have not been all that intense, nevertheless, we've had many gorgeous views over many parts of the world, and I can't possibly show all of the pictures, but I'll highlight just a few. And we'll start with some gorgeous views in Norway. There have been some beautiful views in Norway. And we had some aurora in Finland. And aurora made it clear down to Denmark. And of course, the aurora has been viewed in Scotland. Scotland has probably gotten some of the best views over the past couple weeks. And as we begin to travel over the pond, we've had a gorgeous aurora in Iceland. And as we go to the Western Hemisphere, we've seen gorgeous aurora all over Canada, including some beautiful shots in Yellowknife. And we've had views in Quebec. And lots of views in Manitoba. We've also seen aurora in Alberta. And we've even seen aurora during flights over the Hudson Bay in Nunavut. And believe it or not, aurora has even dipped as far south as to come into the United States. We've seen gorgeous aurora in Wisconsin and in North Dakota, in Minnesota, and of course in Alaska. Can't skip that one. And aurora has even dipped down into the south. We've managed to see it come up as far north, the aurora australis, as New Zealand. And there's been views in Tasmania. And believe it or not, it's even made a show in Victoria, Australia. So what else does our sun have in store for us this week? Well, this is stereo A. It's our partially far-sighted monitor. You can see here's Earth, here's the sun, and here's stereo A staring at the sun just a tiny bit from the side. And when we take a look at stereo A's view, you immediately are drawn to the bright region down in the south on the east limb. On the 9th, this is region 3163, and you can watch it launch this beautiful solar storm, kind of this slow release. And believe it or not, that kind of slow release is really indicative of what we're seeing all over the disk. Even with all the filament launches, there are these really slow and gentle releases. And so we've actually had several solar storms hit Earth, but you know, they're so gentle that when they hit Earth, Earth goes, did you feel something? Anyway, that's going to be pretty much the story, and it's continuing as we speak. So there's not much that we can say in terms of big solar storms that are going to give us some aurora. However, when we take a look at the helioseismology from the JSOC Center, you can actually see a large region or cluster of active regions that's developing on the sun's far side. We won't be able to see it until it rotates into view in about 4 days, but it does look like the sun might have something special in store. Switching to our moon, we are now passing through the third quarter phase on our way to a new moon, and by the 19th, the moon will still be about 20% illuminated. So you night sky watchers, if you want to catch those dim objects in the sky, you're going to need to check your local rise and set times. Switching to our solar storm conditions and aurora possibilities over the coming week, we had been calming down from some fast solar wind over this past week, but you know, we've really been kind of left with unsettled conditions, and these are going to continue over the next few days. In fact, we're really just getting these small little filament eruptions that are kind of, you know, sideswiping Earth and things like that, but they're really not impactful, so it's just going to keep us at where we are. At high latitudes, NOAA is expecting unsettled conditions with up to about a 20 to 25% chance of minor storms, but this is easily going to calm down as we move into the weekend. So aurora photographers at high latitudes, you know, you could get a little bit of a sporadic show here and there. It's nothing going to be like storm time aurora, but it could give you some nice views here and there. But things will definitely calm down unless we get some more substantial solar storm launch. Now, at mid latitudes, we really are expecting unsettled to even quiet conditions, basically normal conditions with very little chance of activity. So mid-latitude aurora photographers, well, it looks like you're going to have to sit this week out and wait till the sun decides to do something more substantial. Switching to our solar flare and particle radiation storm outlook over the coming week, we do have 9 active regions in Earth view this week, and several of them are big flare players. In fact, NOAA's giving us about a 20% chance of a big M-class flare over the next day or two before things begin to settle down. And this is mainly from regions 3153, 56, and 3163. But 2 of those regions are rotating off of the west limb, so you're going to see things begin to kind of settle down. Now, as far as solar flux is concerned, well, you can see we've got mid-range 150s or so that begin to settle down into the 140s. Once again, this is reflecting that a couple of those big regions are rotating to the sun's far side. We do have have a risk for radio blackouts, but it's pretty small right now, and that should make GPS users very happy. But we also have the solar flux staying into the triple digits, well into the triple digits, so amateur radio operators, don't worry, you're definitely going to stay into the good range for radio propagation on Earth's day side. Now, as we take a look at the risk for radiation storms, well, because we have a couple of those big flare players rotating to the sun's west limb, we do have a slightly elevated risk for radiation storms over the next couple days, but we don't have any elevated levels right now. So likely this is just going to settle down and be nice and quiet. So pretty much everything, as far as you frequent flyers, you're all in the clear. So the space weather this week seems to be a bit more bark than bite. We do have a few filament eruptions that are kind of Earth-directed, just partly Earth-directed, but they're so gentle that they really aren't going to cause any big impact at Earth. So aurora photographers, if you're at high latitudes, you could get some sporadic shows here and there. It's not going to be anything like big storm time aurora, but it might give you some nice views. But if you're an aurora photographer at mid-latitudes, well, sadly for this week, you're likely going to be sidelined unless the sun gives us something more substantial. The good news is, however, that we're going to have a coronal hole that'll rotate into the Earth strike zone in about a week or so. So in the long view, things look a little bit better. Now, amateur radio operators and emergency responders, well, we have a lot of active regions in Earth view this week, and they are really not all that active in terms of big flares. We do have a little bit of a radio blackout risk, but it's not too bad, and the noise on the band shouldn't be all that bad, and yet we do have good propagation on Earth's day side because that solar flux continues to remain high. Now the big thing is that we do have a bright spot that's going to be rotating into Earth view in about 4 or 5 days, and that could give us possibly our first big flare player that we've seen in quite some time. So we're just going to have to kind of wait and see what happens. But for the most part, things look pretty good for you. And now GPS users, well, you know what? Things aren't too bad for you right now. The big radio blackouts really aren't that big of an issue, and we don't really have any big solar storms coming. So pretty much your GPS reception all over the globe should be not too shabby. I'm Tamitha Skov, the Space Weather Woman. Thank you for watching.
Thank you, Tamitha. You're tuned to ASV Radio, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, coming from the studios of VK3 CSJ in Narre Warren South. Now, we've got about 7 minutes there, so I'll just go into a report that's come through. Where are we here? Oh, yeah. All right. Apparently a micrometeorite has struck the International Space Station, causing a leak of some sort of coolant. They say here that a coolant link from a Russian space capsule attached to the International Space Station was likely caused by a micrometeorite strike, a Russian space official said. Russia's space corporation Roscosmos and NASA both have said that the incident hasn't posed any danger to the station's crew. However, the leak prompted a pair of Russian cosmonauts to abort a planned spacewalk earlier in the day. And there is a little bit of video here that I can run, which I think it only goes for about 18 seconds, but I think there's a little bit of dialogue there too. Let's just see what happens here.
Stream of particles coming out of the Soyuz MS-22 vehicle that is attached to the Rassvet module on the Earth-facing side of the Russian segment of the International Space Station. We do not know what the source of this stream of particles is. Stream of particles coming out of the Soyuz MS-22 vehicle that is attached to the Rassvet module on the Earth-facing side of the Russian segment of the International Space Station. We do not know what the source of this stream of particles is. to the Rosviad module on the Earth-facing side of the Russian segment of the International Space Station. We do not know what the source of this stream of particles is. Stream of particles coming out of the Soyuz MS-22 vehicle that is attached to the Rosviad module on the Earth-facing side of the Russian segment of the International Space Station. We do not know what the source of this stream of particles is. Stream of particles coming out of the Soyuz MS-22 vehicle that is attached to the Rosviad module.
That should be working. Okay. All right. There's too many switches around here. Okay, fine. So I'm not sure how long that was like that. I think I selected that because of the audio on the video of the coolant venting from the space station there, which I just showed again on the YouTube channel. So, all right, yeah, no worries, Steve. Yeah, look, the FRBs, and I'm acknowledging Dallas's comment too, the fast radio bursts are definitely an interesting phenomenon that's being studied to the hilt. And I think, as Amincia was saying, it's looking awfully like that they are probably neutron stars, similar to a pulsar of some sort. And every now and then we just get lucky enough to be able to see a burst this way. But there are some repeating FRBs. They've been able to find a number of fast radio bursts that do repeat. They're able to see them happen again. But most of them that do get detected, it's just a one-off and never seen again. So that's what they're trying to investigate, what the reasons for that sort of situation. So, yes, all very interesting, isn't it? Anyway, all right. Yeah, and likewise, Aurora, I have not seen yet myself. You know, if I ever get a chance to travel to the States and to Canada, you know, those places, it would be fantastic to be able to see the Aurora, and I'm sure what you would if you travel up that far north. But I know that the Aurora can be seen here on the mainland in Victoria, and there was actually a situation, I think 12 months ago, where there was some very, very good Aurora that was seen as far as South Australia and also in Queensland, I believe. So it just depends on where you are at the time. But yeah, likewise. So I haven't seen it, but I'm looking forward to seeing it. It's my first time. It'll be really good. All right, thanks, Stephen. Okay, and I see that Joe VK3 BKI has come and gone. He seems to. He maybe says he can't hear anything. So maybe the 80 meter transmission wasn't too good to Joe tonight. And Kim's just VK5 SUE's just saying a few things there up there on Discord too. All right, I'll take one more listen on 80 metres for anybody. VK3 EKH, listening 3541. Nothing heard. All right, thanks for everybody. Thank you very much for folks that have called in again over these last 12 months. And, you know, I've been doing the broadcast since 2008, I think. Taking over from Russell Ward, VK3DRW. A lot of the stations that was coming up on Russell's 20 years of the transmission have all but disappeared. I don't hear those stations anymore on the callback. It's probably because I just go for too long. Once you get me on the microphone, that's it. Anyway, but we'll be back again next year to do it all again. Keep everybody up with the latest in astronomy and what's going on. So even if I do decide to, not that I'm thinking about it, but even if I decide to go out on my own, so to speak, and just use my normal call sign rather than the society's call sign, I'll probably continue to do a broadcast just personally for personal reasons, but at this point in time I'll still continue to go under the banner of the Astronomical Society of Victoria, which is one of the biggest societies here in the Southern Hemisphere. So they're doing great guns. On that note, this is VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, concluding transmissions for 2022. Wishing everybody a Merry Christmas and a Happy New Year, and we'll see you all back on the 27th of January next year. Cheers for now. No worries, guys. All right, to those watching YouTube still, thank you for watching YouTube. I've got an air conditioner running here. It's making all sorts of funny noises. Thank you for watching, and appreciate the viewer feedback that I get occasionally. And hopefully when we get back to transmitting on the 27th, we'll have Melbourne Television Repeater back up and running. That's one of the main reasons why I enjoy doing this, is to be able to broadcast through Melbourne TV Repeater. So hopefully by the 27th that'll all be sorted out, which I think it'll probably will be. Meanwhile, we'll be doing the WI broadcast on Sunday morning. If the repeater isn't on air, I'll still run with the WI broadcast on Sunday morning at 10:30 on the YouTube channel, and then that will be it for the time being. I'm out of here. This is ASV Radio, VK3 EKH, wishing everybody a Merry Christmas, Happy New Year. Thank you for watching, and we'll see you next time. Oh, where's my colour bars? There they are. No, colour bars. Up. There we go. All right. Cheers, everyone. Bye.